Welcome to the video for C3.1.3 where we're going to look at conservation of mass. So what you need to be able to do after this lesson is state what the law of conservation of mass is and use that to predict masses. So key facts, you need to copy these down into your book. So the mass is always conserved in a chemical reaction, and that's because when you have a chemical reaction, the atoms aren't created or destroyed, they're just rearranged into different chemicals. So the mass of the reactants is always equal to the mass of the products. So in case we've forgotten, the reactants, sometimes called the reagents or start materials, are what are on the left-hand side of the arrow in the chemical equation, and the products are what we make or produce, and they're on the right-hand side of the chemical equation. So I want you to use this now to try and work out the missing masses. So I'll talk you through the first one. So the arrow separates the reactants on the left-hand side and the products on the right-hand side. So we've said that the mass of the reactants equals the mass of the products. So this means my 4 plus 32 has to equal my product. So 4 plus 32 is 36. Okay, so pause the video and then have a go at the questions 2 to 6. Okay, so hopefully you've got here, so you've got x plus 7 equals 12. So x is 12 minus 7, which is going to be 5. Here we've got 0.48 plus 1.42 equals, so that's going to be 1.90 grams. And here we've got 9.9 plus 5.5. Oops, sorry, I've made the mistake, my arrow's here, so 9.9 has to equal 5.5 plus x. So x is going to be 9.9 minus 5.5, so that's going to be 4.4. And my arrow's here, so 8 plus 7 equals 11 plus x. So x is going to be 15 minus 11, it's going to be 4. And then 0.4 plus x equals 8.5 plus 1.8. So 8.5 plus 1.8 is going to be 10.3. So it's going to be 10.3 minus 0.4 equals 9.9. Let's just make sure that decimal point's out right. Let's just check we've got those right. Yes, good. Right. So although the mass of the reactants has to equal the mass of the product, sometimes the mass will appear to change. And that's when we've got gases in the equation. So if we're producing a gas, then the mass is going to appear to go down. Because if I've got my mass balance here, and I've got my reaction flask, okay, and I've got bubbles of gas being given off, then the gas is going to escape out of the vessel and the mass is going to appear to go down. However, if the reactant's a gas, the mass is going to appear to go up. So if I've got a lump of, say, magnesium here, and I react it with oxygen from the air, then on my mass balance, I'm going to get a certain reading. When it's reacted, I'm going to have that oxygen from the air, which wasn't included on the original mass, is now going to be on my mass balance. So the mass is going to go up. So I've got a few pictures on the next few slides. I want you to pause after each slide and predict what's going to happen. Is it going to go up? Is it going to go down? Or is it going to stay the same? Okay, so pause the video and have a think about what's happening here. Okay, so this mass balance, this 180 grams, is the mass of the water plus the mass of the salt. Okay, and then when you dissolve it in water, you have put all of this salt into the water, but it is still there. So the mass balance here is going to stay the same. It's still going to be 180 grams. Okay, question 2. So I've got some ice here and I'm going to melt it and it's going to turn into water. What's going to happen? Okay, so broadly speaking, it's going to stay the same because every water molecule that's in this ice is still going to be there. Now, sometimes people correctly say that it might change a little bit because when it melts, so this ice is going to be cold. It's going to make this beaker cold, and sometimes you get a bit of condensation on it. So it might go up very, very slightly. Okay, so third question. So I've got a can of Coke. I've opened it. I've not drunk anything, and I've just left it. What's going to happen? Okay, so hopefully you got the idea it's decreased, and the reason it's decreased is that Coca-Cola has lots of carbon dioxide in, and once we open the can, the pressure is reduced and some of that carbon dioxide comes out, so the mass is going to go down. Okay, now we've got some proper chemical reactions, so pause the video and have a think about this. Okay, so this magnesium's reacting with the acid, so let's say it's hydrochloric acid because that's the easiest one to do. It produces hydrogen gas. Sorry, my pen's disappeared. So this is a gas. This is dissolved in the water. This is aqueous, and this is a solid. So all of these will be included in the mass that's recorded on the balance, but the hydrogen will escape, and therefore the mass will appear to go down. Okay, so earlier I gave you the answer to this. So magnesium burns in air to give magnesium oxide. Okay, so we've got magnesium, which is a solid. That's reacting with the oxygen, which is a gas, to give magnesium oxide, which is a solid. So on the balance will be these two solids. The oxygen gas is in the air, so it won't be recorded in the mass balance. So the mass will appear to go up. Okay, so sodium hydroxide, last one. Sodium hydroxide solution reacts with sulfuric acid solution to give sodium sulfate solution and water. Okay, so the simple equation for this is the sodium hydroxide, which is aqueous, plus sulfuric acid, which is also aqueous, to give sodium sulfate, which is aqueous, and water, which is a liquid. Now I just need to balance that. Okay, so because these are all aqueous or liquids, they're all going to be included in the mass balance, so this one will stay the same. Okay, there's some exam questions that are on Teams for you to have a go at, so have a go at those questions and then mark them using the mark scheme at the end of it.